In this briefing, we'll talk about the types of runway conditions and the contaminants reportable through field condition NOTAMs. Under the TALPA initiative, pilots will receive type and depth of contamination reported in the field condition NOTAMs, along with the associated runway condition codes, to determine the effect of runway contaminants on aircraft performance. In this briefing, we'll discuss the different classification of runway conditions, the types of contaminants you might encounter on takeoff or landing, and the different layers in which you might encounter them. We'll also review the definitions FAA uses to identify the particular types of contaminants you might find on the runway. And we'll look at how FAA handles runways that have one type of contaminant layered on top of another, as well as runways with more than one type of contaminant. Let's start with a dry runway. It's often easy for a pilot to determine that a runway is dry, especially if there's no precipitation at the airport. However, even if there is some contamination on the runway surface, it may still be considered dry for airplane performance purposes. With that in mind, under the new field condition reporting procedure, FAA now defines a dry runway as one that's neither wet nor contaminated. So long as no more than 25% of the runway surface is neither contaminated nor wet, the runway is classified as dry. A dry runway will not be reported as such in field condition NOTAMs, nor will the runway condition code for dry be assigned, unless there's a reportable contamination in another portion of the runway. Now let's take a look at a wet runway. It's not dry, but there are no other contaminants present. For the purposes of runway condition reporting and aircraft performance, a runway that is visibly damp or that has standing water up to a depth of 1/8 inch or less is classified as wet. It's important to understand that a wet runway defines a condition, not a type of contamination. And for airplane performance purposes, a runway's surface doesn't have to look saturated with water to be considered wet. It might not be shiny or reflective, which is often a qualifier used by some manufacturers for defining a wet runway. Here's what the FAA recommends. If the ramp is too damp to sit on because of morning dew, the runway is probably in the same condition, and the pilot should use the wet runway performance data. Dry runway and wet runway are conditions. So what are contaminants? There are several types: frost, snow, slush, ice, or water on airport pavement that can be detrimental to the way your aircraft performs. Water is one type of contaminant that can be reported. Now there's a difference here between a wet runway and a runway that's contaminated with water. Water that's on the runway at a depth of 1/8 of an inch or less constitutes a wet runway. But if the water is more than 1/8 of an inch deep, then it's a contaminant. Snow is considered a contaminant. However, it can be reported in 4 different forms: dry snow, wet snow, slush, and compacted snow. Dry snow is powdery. It doesn't stick together because it's just too cold. Here's a rule of thumb: if you can't make a snowball with it, then it's dry snow. Wet snow, on the other hand, contains enough moisture to bond together a solid mass. When it's compressed in your hand, it retains its shape as a snowball, but you can't squeeze any water out of it. Slush is another type of runway contaminant. Slush is snow that has enough moisture so that it takes on a fluid property. Here's another way to look at that. Slush is water-saturated snow that will splatter when you stomp on it. Compacted snow has been compressed to the point where you can't compress it anymore. If you pick up a chunk of compressed snow, it'll hold together, and you can break it into smaller chunks. Ice is considered a runway contaminant, regardless of depth. Melting ice, or ice covered by a layer of water, is considered as wet ice. Frost is formed when airborne moisture condenses on a surface whose temperature is near freezing. Any depth of frost is considered a contaminant. However, heavy frost that has a noticeable depth may have friction qualities similar to ice. That might cause the airport operator to downgrade the runway's condition. The contaminants we've discussed have known effects on airplane performance. So, under the TALPA initiative, a runway is considered contaminated when more than 25% of its surface is covered by any depth of frost, ice, snow, or slush, or by water that's greater than 1/8 of an inch deep. However, there are other types of runway contaminants that may be reported in the field condition NOTAMs, whose effects on airplane performance is not known. For these contaminants, you generally won't find any performance data from the aircraft manufacturer. They include mud, ash, sand, or oil. You might find more than one type of contaminant on the runway at the same time. When this happens, a field condition NOTAM will contain only the two most prevalent types of contamination reported for each 1/3 of the runway. If that's the case, the runway condition code for that third is based on the most hazardous contaminant. You might find different types of contaminants known to have an effect on your aircraft's stopping performance layered on top of each other. For instance, you might encounter dry snow over compacted snow, wet snow over compacted snow, slush over ice, water over compacted snow, dry snow over ice, or wet snow over ice. When this happens, the runway can be much more slippery, and the runway condition codes are adjusted downward to reflect the degraded stopping performance for your aircraft. The runway condition slippery when wet affects skid-resistant surfaces, which include runway grooving or porous friction-coarse surfaces. These surfaces must be properly maintained by the airport if they're going to help you stop when the runway is wet. Factors that can create a slippery when wet condition include rubber buildup on the runway polishing, groove failure, general wear, or poor drainage from the runway. Let's review. Under the TALPA initiative, there are 3 types of runway conditions: dry, wet, or contaminated. You might see dampness or contaminants on a dry runway, but to be classified as dry, they can't affect more than 25% of the total runway area. A wet runway is visibly damp, or it could have water at a depth of 1/8 of an inch or less, covering more than 25% of the surface area. A contaminated runway surface is more than 25% covered by frost, ice, snow, slush, or water that's deeper than 1/8 of an inch. There may be other contaminants on the runway, like mud, ash, sand, or oil, which could have an unknown effect on aircraft performance. And finally, TALPA identifies special surface conditions known to be especially degrading to aircraft stopping performance. And that completes your Level 1 TALPA briefing.